Good afternoon, everybody. Again, we're talking about developing Inventor Assemblies with iLogic. My name is Randy Mabery. I'm on the MSD team, which is the Manufacturing Solutions Division. I've been with IMAGINiT for about 10.5 years now, all on the MSD side. I do Inventor implementations and Vault implementations, assisting clients with Inventor and Vault, AutoCAD as well, teaching classes. But my main focus over the past 9 years or so has been doing automation projects. So everywhere from providing assistance to clients who are working on their own automation, kind of some over-the-shoulder type stuff, to teaching iLogic classes, to building full-blown configurators for clients, all depending on what the client needs are. If you've watched any of these iLogic webcasts over the past few years, then more than likely you've heard me present before. Okay, so I am going to switch to Inventor here. And today we're going to talk about 3 different methods for building assemblies with iLogic. Not only building them, but configuring those. And I've broken them down into 3 different methods of suppressing components. And then there's replacing components. And then we have the option these days of building on the fly. Meaning there's nothing inside of my start templates. These methods don't have to be individual. You can use them in conjunction with each other, and we'll talk about that as we go through here and look at things. So the first thing I want to bring up is, or discuss, is the suppressing components method. This is one of the older methods and main methods, used to be, for building or controlling assembly. All symbol options, right? That together over here component. If I expand, I've built these guys across the top. And then I've got some lower cross members that sometimes are required and sometimes are not required. Again, based upon what this configuration might be. So this is a very simplified model, but it explains what that method and how that method works. Okay, so those components are controlled using iLogic. Specifically using the component.isActive iLogic snippet. And that allows me to suppress or unsuppress components. So I'm going to take a look at my form here real quick. And again, the iLogic form is just an easy way to build a user interface that allows me to enter data, values, customer information, whatever's required to build the model, and then also data that can end up going out on the drawings. Okay, so I've got some very basic frame dimension inputs here. Same thing for my member dimensions. I can control the width and height of the member components, those tubes that we see out there. There's also controls for whether or not I need the upper cross members or I need those lower cross members. That's where the suppression and unsuppression comes in. Sometimes we need them, sometimes we don't. So I'm going to take a look at some rules here real quick. And this is a very, again, simple rule. I'm passing some values down to those lower level pieces, right? If you're familiar with iLogic at all, what I'm doing here is passing top level parameters down to lower level components. Okay, so the width, the height, and length for all those various tubes. Where we get to the suppression down here at the bottom is where my component.isActive snippet is being used. So it's expecting a couple different arguments. It wants to know what is the component name that you're trying to control. And then it needs to know true or false. Is that component active or is that component not active? And when they say is active, it's talking about suppressing or unsuppressing. So when I say a component is active equals true, that means that component is unsuppressed. It's going to take part in my bill of materials. It's going to affect the mass of my assembly. It's just a normal part, right? If I set my component is active to false, it will suppress that component, doesn't take part in my bill of materials, doesn't affect anything else inside of my assembly. Okay, I'm going to scroll down a little bit further here. In here, again, we're looking at those false versions of those. So that's just a simple conditional block. If I could size this right. So on line 48 here, I'm looking at if that cross-member required parameters equal to true, then I turn those components on and I'm passing values down to those components, right? Same thing that we saw up above, my member width, my height, and my length. In my else block, right? So lower cross members required is equaling false right here. So I'm setting those values to false. I don't have to worry about passing parameters in that situation. Okay. I'm going to go ahead and close this. I'm going to hit let's put them 2 inches off the bottom. Hit region frame. It unsuppress those components and then pass those values down, right, to size them as needed. So we can modify and play with that data however we see fit. I'm going to take a quick look at my bill of materials here and we'll see what's going on with those cross members. I'll go to my structured only tab. Actually, let's suppress those. Go back into my bill of materials here, and I don't have my lower cross members or those upper cross members that are showing in the bill of materials, again, on my structured tab. If I go to the model data tab, I see those entities, right, but they've got a BOM structure of reference. So the model data tab is replicating basically what you see in your model browser. Suppressing with the component.isActive snippet sets those BOM structures to reference, which is why they don't show up over in my other tabs. Okay. A little bit about what's going on with the suppression and this version of Inventor. So I'm running Inventor 2022 with some of the updates as well. Prior to 2022, in order to suppress components, I had to have a custom level of detail. Some users who use custom levels of detail without iLogic, or even with iLogic, find it at times frustrating. You might end up getting dialog boxes that pop up and say, you know, you've created a custom level of detail and you don't even remember doing it. So if I right click and suppress a component, not using iLogic to do it, but manually suppressing that component, nowadays I get this message that tells me that that's not going to participate in the bill of materials. In older versions of Inventor, it would automatically create a custom level of detail for me, but you might not notice it until you try to go save that assembly. Some people have a bad taste in their mouth working with levels of detail. If you're suppressing with code and you're in a custom level of detail, it works smoothly. Thankfully, again, Inventor 2022, they got rid. We no longer have levels of detail in our representations folder, and now we have model states. Inside of here, in 2022, I can suppress and unsuppress components in any model state. It doesn't have to be just a custom level. As you can see here, I am in my master level. Okay. Go back through and turn those guys on. Alrighty. Again, still something that gets used these days for suppressing components. It does have a somewhat heavier model at the end. So if you've got a very large assembly that's got a lot of different components and options that might come on or unsuppress or suppress, then at the end, once you've configured that particular assembly for, let's say, a job, you got a lot of suppressed parts inside of that assembly. Sometimes that's a good thing, sometimes it's a bad thing. If you ever need to come back and reconfigure that assembly again, I highly suggest that you leave those components in there for that very reason. If there's no chance that you're ever going to configure this again, I've built this for a particular client. We're locking this one in stone right now. No more changes can be done to it. Then what we do quite often there is you can either delete all the suppressed components, or you could write a bit of code that will run through and delete all for you. But again, if I've deleted members and it tries to unsuppress them, I'm going to get errors, right? It can't find that component. That's another thing I should have mentioned here about the component.isActive rule. This argument right here is the browser node name. That is what is showing up in my browser. Let me resize this a little bit. If I look over here on the model browser, I've got my left lower cross, right lower cross, right? Anytime you're controlling something with iLogic, it doesn't even have to be the component.isActive snippet. Anything, recommend that you go through and stabilize that browser node name, change it to something so that if it gets replaced or it gets changed out with something else, then my browser node name always stays the same and my code will work. That's one of the common questions that we get is, I've built this configurator, I've got the code that runs it, but I go do a copy design inside of Vault, all my file names change, my code doesn't run anymore. If you leave the browser node names as they are, then I'm going to get, again, what that file name is showing here. And if that file name swaps out, then I've got a new browser node name there, and then my code doesn't work anymore. So what we want to do in that situation is just rename that browser node to something generic. We'll see that a little bit in the next example as well when we're doing a component replace against something. As we see on mine here, I've just called them what they are, right? Left front vertical, left rear vertical, etc. Alrighty. So I'm going to switch and start talking about doing a component replace. Let me launch my form on this one. This looks very similar to the last one. All of these assemblies are rather simple little tube frames. In this case, I'm controlling the same information with my form, the length, the width, the height of my conveyor in this case. Again, my member dimensions. Here I can control what that roller diameter is. So I've got options of a 2-inch roller, a 3-inch roller, or a 4-inch roller. As well as form. I'm going to take a look at my roller pattern here and notice that my first element in here is simply called roller. Again, I've stabilized that browser node name and changed it to something else. If I look at the second element or third or fourth or whatever, we'll see the actual file name there. This one's called Webcast Roller Underbore 2 for the 2-inch roller. And then the occurrence number, right? This is the second occurrence in here because it's in a pattern. I only have to really stabilize the first browser node name, typically. Very rarely do I ever have to change something else. Again, my code is going to swap out or replace this roller with another roller. And since it's part of a pattern, right, all the others are going to swap out as well. So I've only stabilized that first browser node name. So I'm going to take a look at the rule here, my members rule. And again, we're doing some calculations up here at the top. I'm getting some information from the form or from the user interface. And then I'm passing that data down to those lower level components, right? I'm pushing the width and the height and the length down to the various parameters inside those lower level components. Here I'm controlling the color, right? So I'm setting that color parameter multi-value list and then controlling what the color of those components are equal to what that parameter is. Starting here on line 63 is where I'm doing my component replace. So this is a simple select case conditional block. I'm looking at the roller size parameter. And again, I have the options there of 2-inch, 3-inch, 4-inch. Inside of each one of those conditional statements is where I'm setting the roller diameter. And then I'm doing the component.replace snippet. So the component replace needs 3 different arguments here. The first one is, what is the component that you're swapping out, or what are you doing a replace against? And remember, our browser node name over here is just called roller. The second argument here is the file name of the component that you're doing a replace. Okay. So I'm grabbing the 2-inch version, the 3-inch version, or the 4-inch version. The third argument here is, am I replacing all of the instances that are inside of the assembly? Or am I only replacing the single one that I called out here? If we think about that, I've picked the component here. I'm picking a new assembly to swap it out with. And then I'm saying, yes, replace all of them. It's very similar to if I actually came to that component. Let me switch to part priority. Right-clicked on it. Came down to component. Oh, let's do it on this guy. Am I doing a single replace, right? I would only be replacing that single entity that I select on, or am I doing a replace all? That's that third argument that's in there. If I choose replace all, then it's going to want me to pick another file name, right? Or even if I choose replace, I'm going to pick another file name. So again, that's basically what we're doing here with this. It will follow the same format as Inventor follows for trying to resolve where that file is located. These assemblies are in the same folder as my assembly is. Okay, so the path that Inventor follows of, is it a library path? Go look at library, the library folder. Is it in my workspace? Is it in the folder the assembly's in? The component replace is following that same pattern when it goes and tries to do the replace against it. Okay. If I scroll down a little more, again, I'm passing some data down there to the various portions of the roller. So in this case, I have standard 2-inch, 3-inch, 4-inch, but I'm allowing that width to be anything. More than likely, you wouldn't be doing this if you build these a roller bed conveyor like this, right? I'd have standard widths, and I'd probably be swapping out with a standard component. In this case, I'm swapping out with a component, but then I'm configuring it as well. And then again, here's our friend component.isActive. So I'm doing both component replace and the component.isActive in the same assembly. Okay, and here I'm again turning on or off those lower cross members, passing data down to them, setting their color, or I'm unsuppressing them. Okay. If we've decided that we need that top pattern, I am running a subroutine inside of here called create pattern. We'll see it at the bottom of this rule. Another thing that you might do sometimes with while inside of an assembly or trying to configure assembly is control the constraints of something. I could always suppress and unsuppress components if I have it in multiple locations. The serial number tag is a great example of that. I give the user the option of putting it on the left-hand side or the right-hand side of my assembly. I could always have two different serial number tags inside of the assembly and suppress and unsuppress whichever one I need. In this case, I only have one inside of my assembly, and I'm controlling the constraints of where that goes. So the constraint.isActive works very similar to the component.isActive. In this case, again, you want to rename those constraints so it makes sense to what you're trying to do. If I was in here and looking at flush 239 and mate 184, I don't really know what's going on there. If I look at this and it's the serial number tag, face mate right hand, end flush right hand, and then the mid plane, I know what those constraints are doing. It makes sense to me, right? So again, a simple conditional block where I'm suppressing three of them and unsuppressing three others. And then on the right-hand side, I'm unsuppressing the right hands and I'm suppressing the left hands. Okay. And then my pattern, my create pattern down here, iLogic does have the ability to create patterns now. This is done with some API code, but it's very similar to what we'd see in the other situations. So I'm going to go ahead and close that and launch my form, and we'll see what goes on. So let's pick a 4-inch roller and say my max roller spacing is 6 inches. We'll go a longer, wider, slightly taller. Maybe we'll make them green. And then I'll switch the serial tag to the left-hand side. Hit my build frame button. Right, and there's my new version of what this conveyor needs to be. So it swapped out or did a component replace on those rollers. If I take a look at my browser node name again, right, it's still roller, but if I look at the second one, right, all of those have been swapped out with the 4-inch. My serial number tag is no longer on the right-hand side. Right? He's now over here on the left. And if I take a look at the constraints for him, same thing that we saw when we're suppressing components. These top three are suppressed, and then the bottom three are the ones that are turned on. In that situation, if you're trying to control constraints like this, you would add the 3 or however many are required to fully constrain that component, suppress them, and then create the other 3, rename them all, and then go worry about building your code. Okay. So that's component replace. Now let's look at building on the fly. So I've got 2 different methods in here for building on the fly. Inventor 2019 gave us the ability to add components using iLogic. If I create a blank rule here, now we've got, again, since 2019, I've got this iLogic Assemblies components category, which allows me to manage components and add components, add iParts, add content center, etc. Here's the patterns that I was talking about earlier. Previously to 2019, you had to use the API in order to add components, or again, build these things on the fly. So I've got two different versions of assemblies here. One of them is using, again, the older method or using the API to insert components. And I'm inserting them where they need to be in space. And then I'm grounding them. The second assembly that we'll look at actually uses the iLogic snippets and adds the components and then constrains them where they need to be. Okay. So notice there's nothing in my assembly here now. I'm going to launch my form. Very similar to what we've seen before, my various options for length, width, height. Whether or not I need to have, again, patterning those top members. When I hit build frame here, I don't know how easily you can see it because of the webcast, but it inserts these components at 0, 0, 0, and then it moves them into the situations or location XYZ where they need to be. If I look at my browser node over here, all of these are grounded members. I'm sorry, they're grounded components. I can hit delete frame here. It will run through and delete all the components inside of there. Or I can simply run the build again with different numbers. And we'll do a much smaller. I hit build in this case, and it's going to go through and delete those components, go make new copies again, and then put them into the assembly. Again, in the XYZ locations where they need to be. So we'll take a look at these rules. My delete all members, again, this is using the API as opposed to using Inventor. And I want to show the difference of or what happens when I'm using the API versus using iLogic. So in this case, all I'm really doing is looping through all of the occurrences, and I'm going through deleting a pattern, if it's a pattern, and then I'm deleting the components. Okay, so very simple in that case. That's what runs if I choose the delete frame button on my form, and that's what runs at the beginning of every insert members. Okay, so let's take a look at this one. Again, I'm inserting members at my proper XYZ, and then I'm grounding them. Okay. So I'm simply running that other rule with the iLogic run rule, running the delete all members command. I'm doing a bunch of declarations here, right? Getting an assembly document information, getting my browser node, my browser pane, setting my file paths that I want to use. I'm creating a directory, right? Maybe my output path doesn't exist. If it doesn't, then I need that to exist before I go start putting files in that location, right? So in this case, I'm creating that directory. Everything inside of the API is in centimeters, right? So if I go look at parameter values through the API, those values are going to be in centimeters. My parameters inside of Inventor are in inches in this case. So I have to have a multiplier in here. Since I'm not setting the parameter values with a typical parameter snippet, and I'm accessing them a different way, I need to control certain things, again, with that conversion value. That's what this centimeters to inch multiplier is. Okay. So here's where we start looping through and putting in those pieces. I've got a simple list here of the various components that are needed. The left front vert, the rear vert, the right front vert, the right rear vert, etc., etc. So I will loop through that list, and for each one of them, I'm going to go make a copy of the template part. I've got a component here called rectangular tube or webcast rectangular tube. I'll go through and copy that and save that as a new part inside of my output folder. That's what's going on right here, but lines 66 to 76. By the way, this is the latest update for Inventor. So they finally gave us these line numbers, which is great. If you've worked in any other development environment, you probably miss those line numbers inside of Inventor. Now, if I have an error on an iLogic line, that error will pop up and say, there's something wrong with line 70, which is much nicer. I know exactly where the issue is. Okay. So then, based upon whatever part I'm putting in, I know where that part needs to be based upon parameters that I created. Right? So I'm setting the X and the Y and the Z position using those values. So half the width and then minus half the member width is where the left front vertical needs to go. The left rear vertical is the negative of that. Setting the values, and I'm setting the rotation values. Same thing with rotations, or I'm sorry, angles inside the API are in radians. So I don't know why I didn't make this a variable. I should have made it a variable like I did the other, but that's why all of these values are getting divided by 57.295, because that's a radian issue. Okay. Again, a simple select case here. We're looking at those values. We're setting the XYZ depending on which part I'm putting in. And then line 156 here is where I'm actually inserting that new part file based upon the matrix of where that component is required to go. Okay. I'm then grounding it. In this case, remember all these components are being grounded. And then I'm renaming the browser node name. I want the browser node name to be whatever in this case, the file is called. And then pretty much the bottom here is like we saw before. I'm passing values down to those controlling values. Okay, so let's launch my form again. Build that frame without those top cross members. So the difference here is I don't have those components that are suppressed, right? The only thing that's going to be inside of my assembly at the end are the components that are required for this specific configuration. Okay. I don't have pieces in here that are turned off. And I didn't have to ground these in this situation. It's just another option, right? I'm not going to end up coming in here and moving things around. So I was okay with grounding them. Go ahead and delete that guy. I'll save him. And let's take a look at the iLogic version of doing that. Again, with this one here, I am building constraints inside of there. So if I look at my model browser again, right, there's nothing inside of here. I do have some work planes, but there's no components in here. If I take a look at my form, very similar to what we saw before, controlling the various length, width, height, the colors, what my roller size is, and what the max spacing of that roller is. If I hit build assembly, again, I don't know how quickly it shows coming across here, but it's putting those pieces in at 0, 0, 0, and then it's building constraints. So if I take a look at my model browser, right, the same kind of components that we see here, but they're not grounded, right? They've got constraints against them. Standard Inventor constraints, nothing special about them other than the fact that I have renamed them, right? Again, serial number tag 1, 2, and 3. the front right, the cross member. Right? As I'm creating those with the code, I'm giving those constraints a name as well. So let's take a look at the rules that do this. So again, I'm displaying some constants up here. What's my roller offset, etc. Getting the values of my roller. I'm doing some calculations on that to figure out how long some pieces need to be. What's that vertical leg length need to be? What's the mid length needs to be? And then I'm getting the appearance asset based upon what that color is. Right? So when I put these in, that's one of the options that I can use, or one of the arguments is to apply an appearance to that entity. Right? So we see here, these are all coming in there as red. Right? If I set it to green, it's just like selecting that entity and doing an appearance override here at the assembly level. Right? I'm not affecting the lower level component. I'm modifying what that occurrence inside of this assembly looks like. Okay. And here's where the nitty-gritty starts happening, is where I'm adding those components and I'm constraining those components. So again, with Inventor 2019, we had the options of adding a component. And I'm going to add that snippet right here just so we can look at it. I'm not using all of the arguments that come in here. Some of them are can be assumed if they're left out of here. So if I add that snippet, that's what it looks like here, dim component A, and then the add method against my components collection. What's the browser node name going to be? What's the file that you're putting in there? And then are you applying a position to it? Are you grounding it? Do you want to control its visibility on or off? And do you want to control the appearance? So if we take a look at my component adds here, again, I'm supplying the browser node name, the file name, and then just the appearance. I'm not going to control the position because I'm going to control that with constraints. I'm not controlling whether it's grounded. The constraints are going to handle all that for me, and then I'm not controlling the visibility. You'll also notice that I have a begin manage up here. And if I scroll down to the end of all this, there is an end manage. This handles the deletion and the insertion of the components inside of that block. If there's something in the assembly that doesn't exist inside of that managed area, iLogic will delete it for me. I don't have to worry about using the delete component snippet inside of here. Okay. So going back up a little bit, here I'm adding all of those various members of my frame. And then on line 41 here, I'm adding my serial number tag. If the length is greater than that mid-support minimum, right, we set that at 72 inches up here. So if my length is greater than 72 inches, I also need 2 additional components. So add the front middle vert and the rear middle vert. Swapping out, or I'm not swapping out, I'm sorry, I'm adding the correct roller, just like we saw a little bit further up top. And then I'm creating constraints. So for each one of these entities, I have a constraint name. What is the component, the first selection component? And then what is the entity in that first selection component? And then the second selection component and the entity in it. Right? Just like if you're doing a constraint inside of Inventor, and then any offset values. I don't have second components in this case because I'm constraining the first article or first component that goes in there to the origin planes of my assembly. If I scroll down a little bit, we'll see, for example, here on line 77, I'm constraining the front top cross to the left front vertical, the right face to the front face. The easiest way to handle those faces are to go create those on your own, those named entities. You can allow iLogic to do it for you, but it will call them face 0 and then face 1 and face 2. Again, I like to have more control over that. I know when I'm constraining, so I will create those named entities and those lower level pieces on my own. So it looks like this is a lot of work if you look at all of these constraints. Looks like I did not rename some of these here. The easiest way to do that is to go ahead and build the assembly, again, using standard tools. And then I can use the capture current state of those entities, and it will build all of these for me. Okay, I'll show that here in just a second. So I'm passing my parameters down to the lower level parts, doing some calculations here again on patterns, and then I'm adding that pattern. Okay, so again, if I came through and deleted all of these pieces, go back to component priority, right, and said it's now cyan and I need a 4-inch roller at 8 inches. And let's go our length here to be greater than what that value for my minimum is, and hit build again. You probably saw it, all the stuff at 0, 0, 0, right? That's because I'm inserting them with no position, right? I didn't use a position here on my components.add. And then later is when I start constraining those. Okay. So in this case, there's those mid verticals that are required because my length has got so long. Okay. One more thing to take a look at here is this serial number tag, right? I've constrained this to its to the tube, and this is the good method for building that components.add and then the constraints.add, right? He's in there as he needs to be. He's constrained where he needs to be. I've built the whole assembly that way. So then inside of my iLogic rule, I can go to that component and right-click on him, and I have 3 different methods there for capturing the current state. The first one is it active or not? It's just going to build that component.isActive rule for me based on the current state of that object. I can use the components add, which builds the components add for me. Right, there's the browser node name and there's the component that it used. Or the most helpful generally is the bottom one there. It handles the component add and the constraints add. So this would add this file name with this browser node name and then build these constraints. This is what I did on the original rule. I built it as it needed to be. I constrained it as it needed to be. And then I used the capture current state. And I end up with the various code to put that in. Okay. And that's it.